take a look at this series. Usually, well, as usual, with the infinite series, you want to know whether it converges or diverges. Something to remind you of, if the question asks you what is, well, if it converges, what is the limiting value? Remember, you really only, at this point, and by the way, at this point when I say, I'm speaking to just Calculus 2 students, at this point, there are only two kinds of series, really, that you know the limiting value of convergence. Geometric and telescoping. If it's not geometric or telescoping, you have no really way, no tools as of right now for finding what that series converges to. First glance, you might be thinking this is geometric. If you just start to plug in some values, which is always a good idea, if you're lost with this, start writing some stuff down. I mean, who knows, you might get points for it, right? So write some things down. If I plug in 0, I get 1. If I plug in 1, I get e to the negative 1. If I plug in 2, I get e to the negative 4. If I plug in 3, I get e to the negative 9, etc. Now ask yourself if this is geometric. If it is geometric, I can figure out whether it converges, I can find a limiting value, etc., while assuming the common ratio is between negative 1 and 1. Is it geometric? No, it's not, because each term, I don't multiply a constant to get to the next term. So not geometric, so damn it. All right, so what are my other possibilities? What does the divergence test say? What does the divergence test say? If I do the divergence test, just take the limit as n goes to infinity of this guy tends to 0. Oh, that means that it converges, right? No, it does not. Divergence test only tells you whether the series diverges or not. Be careful with the logic there. If the sequence did not tend to 0, then I say it diverges. So nothing I can really do. Okay? Maybe the integral test will work. Okay? I'm in Calc 2. I'm not really, but I'm pretending like I am. And I'm thinking to myself, okay, well, I like integrals. Okay, at this point, I like the integral test. I can take integrals. Can I integrate this? Can I just take maybe the integral from, say, 1 to infinity, right? There's some hypotheses it has to satisfy, like decreasing, etc., of this thing, e to the negative x squared dx. If you haven't learned yet, I mean, just try for a little bit. Go ahead and try to integrate this. Maybe one day you'll learn how to integrate this. A very fancy technique. I'm not going to get into the details, but this has no antiderivative. Now it turns out you can actually use the bounds of integration. When you have a definite integral, you can compute this. But when I say it has no antiderivative, this piece, there's no antiderivative for this. U substitution, none of that business works. So that's a fail. What else maybe do I want to resort to? Well, at some point, if you have learned it, maybe you could do something like the ratio test, or possibly the root test, let's have a power of n. But what I want to do here, and I guess I've only been doing videos about this in particular, is the comparison test. Okay, so I'm going to do a comparison. So let me give myself some room. I think one of the tricky things people have, of course, is what to compare it to. What to compare it to. One thing you may want to think about is, do you think this is going to converge or diverge? That's one of the things you may want to ask yourself. Okay, one thing you should also think about is the fact that e to the negative n squared is the same thing as 1 over e to the n squared. Alright, so think p-series. If this is 1 over n squared, it absolutely converges. Now ask yourself, what grows faster, n squared or e to the n squared? This is an exponential expression. They grow pretty damn fast. So I'm thinking to myself, maybe it converges. Here's me thinking to myself, converges. Question mark. Now, of course, I'm not going to be silly and just say it converges and say abracadabra, wave my hands, please give me points, it converges. No, we can absolutely not do that. So what am I going to do? Like I said, I'm going to do comparison. How am I going to compare this? Well, as I mentioned, n squared seems like a viable candidate. So I'm going to draw a picture. I'm going to draw a picture here. Here's my picture. And if you're not convinced by the picture, I mean, maybe I don't even have my pictures down right. Well, I'll give you another way to convince yourself. Here is n squared, e to the n squared. I only care about n greater than or equal to 0. So when n is greater than or equal to 0, here is e to the n squared. It grows quite rapidly. I want to compare this with, so here's y equals e to the x squared. I want to compare this with x squared, with just plain old x squared. X squared you absolutely need to know, parabola, it's going to look something like this. So the first quadrant looks something like this. This is y equals x squared. N's, x's, doesn't matter. So this is what we have. Now what I want to say is the following. This is the comparison I want to make. So notice that e to the n squared is absolutely greater than, is strictly greater than actually. It's strictly greater than n squared. Now, as I mentioned, if you're not convinced by this, you can do something else. Here's another way to convince yourself. Take a trip back in time when you're in algebra and you had to graph something you didn't know how to graph. What did you do? You plotted points. That's right. So try this sort of thing. What if I just compare n with e to the n squared with n squared? Okay? Do this sort of thing. Plug in a couple of values of n. Well, if n is 0, then this is 1, and this is 0. If n is 1, then this is e, and this is 1. E is 2.718, so clearly this is bigger. Larger. If I plug in 2, this is e to the 4, and this is 4. E to the 4. Is e to the 4 bigger than 4? Absolutely. I mean, you don't need a calculator to verify this. If you keep going, it's also true. Now, what am I going to do? Okay, well at this point, I have a comparison that makes sense. Reciprocate both sides. So this tells me that 1 over e to the n squared is less than 1 over n squared. And I have it. I'm convinced. I mean, if you have this work in your paper, it helps as well. We know something about this. This is p series. So since the sum from n equals 1 to infinity of 1 over n squared, again, it doesn't matter that this starts at 0. I can only plug in n equals 1, but look, I mean, for n greater than or equal to 1, this series I have is going to be less than this. This converges, p series. Make sure you write p series, right? Always want to justify everything. Don't have any gaps in basically in your explaining, in your justification. Hence, therefore, well, actually, just say then this series also converges. E to the negative n squared converges by comparison. And actually, if you go back to the integral I had earlier, if I integrate this, we didn't know the antiderivative, but you should be thinking that integral should converge as well. And it does. It's related to the normal distribution probability. All right, that's a whole other day. This is my result. Comment on the example, question on the example. Also comment an example of something else I'm going to go over. And thank you for watching.